a Bug Blitz mosquito repeller from Poundworld. So this is a little unit that's supposed to repel mosquitoes, and it's got a little LED built into the end. And this got off to a very bad start because the batteries inside were just corroded to bits, and it did really damage the contacts. So I had to open it up and scrape the contacts to get this to work and put some different batteries in. So it's got the little yellow LED light in the end, and when you turn this little switch on at the side, I don't know if you're going to hear this. It makes a high-pitched noise. Can you hear that? But it makes a very low-level high-pitched noise, and I think the idea is that it emulates some sort of predatory insect that maybe has a lower frequency than the mosquitoes or midges themselves. And it makes them think they're going to get eaten, and they sort of steer clear of that area. And it's notable that if you press the button, let's see if you can hear this. Yeah, the frequency changes when you push the button because the voltage is fluctuating in the battery, so it's not like a sort of accurate frequency. So let's open this. So off comes the cover. 2 screws hold it shut. I'm not sure I'd trust one of these to get, to avoid being bitten by insects. Maybe they do work. Yeah, I suppose some of you will have experience of whether they work or not. So the contacts are just a couple of rivets onto the circuit board. This one somewhat darker than it should because I have thoroughly scraped it. And it's got a little piezoelectric disc on this side. A piezoelectric disc is basically a layer of crystal that's stored. If you raise it above its Curie point temperature and apply a voltage across it and then let it cool down, it kind of holds a charge. And when you flex it, it will generate voltage, or if you apply voltage across it, it will distort. It just seems to give it an electrical characteristic. And there's a 2-transistor circuit here with a few little resistors and what looks like a capacitor in there. And at the other end, it looks like the clicky button is just basically shunting the LED right across the cells. Okay, I'm just going to doodle this down and we can take a look at the circuitry. Well, the circuitry is not what I was expecting. It's quite intriguing because it's based on a standard A-stable multivibrator. But instead of using the 2 capacitors, one of the capacitor positions has the piezoelectric transducer. And, these are basically sound-producing capacitors if you look at them in that sort of perspective. And because there are 2 parallel plates, I'm guessing they probably match the value of this one to match the capacitance of this. But it means that the 2 transistors are going to alternate backwards and forwards at a frequency based on the value of these capacitors and these resistor values. And they're very high value resistors for such a low supply voltage of about 3 volts. The current is going to be really, really low. But because of the circuit arrangement, it is going to have a sort of push-pull effect, and that's going to produce the audio tone at very low level from this disc. It's very intriguing, quite like that. So that's got a switch to power that section if desired. There are the 2 button cells, and then the LED is just this clicky button on the circuit board shunting the LED directly across the cells to light it at the highest intensity, which, yeah, it's a common approach in sort of, the keychain flashlights. But it would have been nice if they'd chosen a white LED. But having said that, that means that if the batteries were running below about 2.5 volts, this just wouldn't emit any light at all. So I can understand why they've just used a standard yellow LED on that sort of low voltage supply. But yeah, that's quite intriguing. I quite like that circuit. It's quite novel.